All right, parent function number 10.
This one's called the logistic function, and it may or may not be new to you depending on if you've had FST. Actually, it's probably new for everybody, isn't it?
Probably.
Okay, so again, just like in exponential and logarithm, you could have different bases. Logistic is a version of that, and it could also have different bases. For right now, we are going to use 1 over 1 plus e to the negative x because it's easier to remember. When we get to chapter 6, we'll deal with what if it's not a base of e. Okay, for right now, all we need is one ordered pair and two horizontal asymptotes. So what is our ordered pair going to be, Mr. Lucky?
Well, in this case, when we use this function, our ordered pair is going to be 0, 1/2.
Okay.
It's actually going to be our y-intercept. As we transform this function later in the year, that point actually will change. But for now, it's going to stay there. We also have two horizontal asymptotes. The first one is going to be at y equals 0, which will not change with our other logistic functions.
Correct.
And the other one's going to be y equals 1, which is really just going to correspond to this numerator up here of our function. If that changed to a 3, then our horizontal asymptote would end up being a 3. And we'll deal with that later in the year. But for now, we're just going to go between 0 and 1. So we have a horizontal asymptote at y equals 0, a horizontal asymptote at y equals 1. And a logistic function basically grows like an exponential function, but then it has a limit to its growth. That's why the upper horizontal asymptote is there. So it starts off almost looking like an exponential function, and then we'll flatten out and reach a limiting value near the top. Okay?
The domain is going to be all real numbers, so from negative infinity to infinity.
This should be pretty obvious based on the picture.
And again, with all these, if you can graph the picture, you can list all these attributes. The range would be from 0 to 1, not including either one, because you can't actually reach those asymptotes. There is no symmetry.
None.
But this time we're going to say bounded. And remember from our definitions in 1-2, bounded means bounded above and below. Okay? There are two horizontal asymptotes, so they are at y equals 0 and y equals 1. There are no discontinuities. And we are increasing on the entire domain from negative infinity to infinity. There are also no extrema. The end behavior, so the limit as x goes to negative infinity of that function, 1 over, sorry, we could have started with positive. That would mess them up, wouldn't it? Negative infinity of 1 over 1 plus e to the negative x is going to go to 0. Okay? The limit as x goes to infinity of 1 over 1 plus e to the x, sorry, e to the negative x, is going to go to 1.